In this lecture, I'll talk about a few more ways to analyze use cases and requirements. A very basic way of analyzing use cases and requirements is noun-verb analysis. Nouns give you concepts, and verbs give you relations. You need to be careful though with this technique, since that mapping is certainly not perfect. For example, here are two phrases. If you look at the nouns, it's not immediately obvious which of these should be part of the domain model. The pros of noun-verb analysis are that it's easy to do, and it's a very different process from thinking about the actual implementation. The cons, it's very imprecise. You may end up with way too many concepts in your domain, and finally, there's no notion whatsoever of design principles here. So here's another way. You could use the principle encapsulate what varies and translate that into an analysis process. This leads to the commonalities and variabilities analysis, CVA. First, you identify the concepts in your domain, the commonalities, together with the different realizations, the variabilities or variations. Then you encapsulate those variations by specifying a common interface. And you can derive this interface by looking at the possible implementations and determine what is common among them. In the CAD/CAM software example we saw earlier, there are several commonalities and variations. For example, there are different versions of the software, so the version is the commonality, and version 1 and version 2 are the variations. There are also different features, slots, holes, and cutouts, which are the variations, and so on. You can write these commonalities and their variations in a table like this, and it gives you a CVA. Normally, you already know what the variations are in the domain. This is, after all, what you should have found when you created the domain model. Look for possible pairs of entities where one entity is a variation of another one, or where they're both variations of something else. Make sure to keep commonalities singular. In the case of CAD/CAM, commonalities are features and versions. Keep them separate, otherwise you risk ending up with a design that has weak cohesion. Let's look at the CVA table again. How do you turn this into a design? There are a few design patterns that are specifically aimed at capturing variation, in particular the strategy and the bridge. When translating a CVA into a software design, these are generally good starting points. In short, the CVA process starts with identifying commonalities, creating abstractions for them, then defining what variations there are for each of these commonalities, and finally, you need to think about how the commonalities are related. You can also design by directly applying design patterns. This approach relies on you detecting patterns in the concepts and relationships in the domain. When you start with the CVA, you focus on the abstractions in particular and think about the actual relations later on. This means that with CVA, you'll probably find the useful abstractions first, while with design patterns, you will sooner find the relations between concepts. Next to noun-verb analysis and CVA, you can also use something called the analysis matrix. The analysis matrix also deals with variations, but then in different scenarios. The Dutch study grant system is a good example of a system built on scenarios. For each scenario, there is a menu item and a flow to go through. Systems like the Dutch grant system become complex quickly because there are so many different cases and variations. The tax system has a similar problem. So how do you design software that can handle this? This is where the analysis matrix excels. While the CVA focuses on identifying abstractions, the analysis matrix uses scenarios to identify the most important features. You proceed through each of the scenarios and create a matrix. The rows are rules and the columns refer to specific situations. You can then identify design patterns from this analysis and create a high-level design. Let's look at an e-commerce example. We want to build a sales system for Canada and the US. There are varying rules regarding shipping, currencies, tax, and so on. There are two main situations. The customer is in the USA or the customer is in Canada. So we then look at the key features of a single case or scenario. Selling in the USA, for example. In the next step, we grow the matrix to also handle the Canadian sales case. The nice thing about the analysis matrix is that by analyzing per scenario, you can quickly find out if there are any gaps in the requirements. For example, you may find out that there is a maximum parcel weight that FedEx will accept in Canada. If this information is missing for the US, you can ask your customer to supply it, since they might have forgotten to do so. When you extend the design by adding new countries, you may need to add more rows as well, as you discover more variation. If you add shipping to the Netherlands, you'll have to handle a new currency, but you also might need to add a variety of date formats, or custom clearing delays that you need to take into account for planning the shipping. A scenario-based approach, such as analysis matrix, is also helpful when talking to customers, since customers understand scenarios very well. Customers are also not very precise as opposed to scientists, so you will probably get better information from them by guiding them through scenarios and examples, as opposed to flat out asking what the variations are. In the analysis matrix, each row corresponds to the implementation of some kind of general concept, such as shipping rate or date format in the e-commerce example. Depending on how complicated the variation is, you can either put the responsibility in the class itself, or introduce a design pattern, such as strategy or bridge, that encapsulates the variation. You use CVA and analysis matrix to identify variation in your domain. They are similar, but the focus is different. CVA is driven by analyzing the domain model and identifying abstractions and their variations. An analysis matrix, on the other hand, relies on use cases and structures the information according to the flow in a use case. You can actually use both and see whether one of them leads to more insights into the system you're trying to design. This is the end of the video about CVA and analysis matrix. If you have any questions, please post them in the Teams channel of the course. Thanks for watching, and catch you in the next one.